Hi, so here in this video we would uh, talk about the condition where what happen if we add nuclei already in the cell. So in a normal condition, uh, during a polymerization of the G-actin or the actin filament. Okay, so in a normal condition there would be a three phase at which we have learned already: the nucleation phase, elongation phase, and the steady state. Here in the graph 1, on a left side it is denoted, the axis is denoted by time and y axis by mass of the filament. So as the time passes, the mass of the filament increases. So in the first phase, the nucleation phase, there is a little by little increase in the mass of the filament, but as the elongation phase comes, there is a sudden increase in the length of the filament. But as the phase third, the steady state, nearby the equilibrium comes, the filament or the mass of the filament becomes steady, or the plateau occur. So it's a normal condition, okay, but here on the left side what happened if we already added, the nuclei is already added in the cell, so there would be no happening of the first phase, nucleation phase. Okay, so if there is no nucleation phase, because nuclei is already added by our cell, by us in a cell, so there would be a sudden increase in the second phase, or the sudden polymerization or elongation of the filaments would happen. So there would be a no first phase, no nucleation phase in the cell during actin polymerization. Okay, so now the next point is critical concentration. So what is critical concentration? It's a concentration or a minimum concentration of G actin at which actin filament form. So it's not like we add just one G actin and the polymerization start. There would be a need of minimum amount of G actins. As the cell reaches that concentration, then only the polymerization would occur. Okay, so that is a critical concentration of the cell, or just a critical concentration. So in vitro, if we done polymerization in vitro in labs, the critical concentration of G actin is 0.1 micromolar, and below the graph is shown that is mass, which is shown at the y-axis, and critical concentration at the x-axis. So here in this graph, if the critical concentration of the G-actin is already there in the cell, then there would be a formation of the filament, actin filament. But what if there is no critical concentration, or there are no minimum amount of G actin present? So in this case, there would be no formation of the actin filaments, because cell actually needs a minimum amount of G actin. If there is less than that minimum amount, then there would be no formation or polymerization of the G actin. So yeah, that is all about the polymerization of the G actin. In the next video we would discuss about the treadmilling of the actin filament. Okay, thanks a lot.